Yes. In this video, we will understand about how to calculate probability for a binomial distribution. In one of our previous videos, we have posted on how to calculate probability for a normal distribution. So in that video, we have explained about the concept of probability, absolute probability, and cumulative probability, and how to calculate probability for a data which is normally distributed. In the description of this video, I will share the link of that video. So people who have not seen that video can see that. It will give you an understanding. Anyway, as a recap, let me explain the concept of probability, then take you to the probability for binomial distribution. So what do we mean by probability? Probability in a very simple term is nothing but chances of a particular event occurring. So in this example that you see here, we all know the die that we use to play for a Ludo. So it has 6 faces. So when you spin a die, you have any of those 6 faces coming out as the option. So that means your total outcomes, when you spin a Ludo die, your total outcomes will be 6. 6 is your total possible outcomes. And when you spin a Ludo die and you are calling 3, then your preferred outcome is one of those 6 outcomes, right? So total outcomes are 6 and preferred outcome is one of those 6 outcomes. So 6 and 1. Now, how do you calculate probability? In a very simple way, the formula for probability is preferred outcome divided by total outcomes. So in this case, the probability of an event occurring is 0.166. Now, when you spin a Ludo die, what are the chances of you not getting a 3? Then how do you calculate that? The formula for an event occurring is preferred outcome divided by total outcome. And the formula for an event not occurring will be 1 minus probability of the event occurring. So the chances of you not getting 3, anything other than 3 will be calculated as 1 minus probability of the event occurring. So that's what I have shown here. Now, this is probability of an event occurring, and this is probability of an event not occurring. Now, what is cumulative probability? So, cumulative probability is nothing but combined probability. For example, what is the chances of you getting an even number? So, your total outcomes are 6. And what are the chances of you getting an even number as your outcome? So, then what will happen? Among this, 2, 4, and 6 are even numbers. So you can spin a Ludo die and it can come up in any of these 6 outcomes. But you are saying, what are the chances of me getting an even number? So then what will happen is you will calculate the cumulative probability of you getting either 2, 4, or 6. This is what we call it as cumulative probability. So in this case, how is it get calculated? My preferred outcome will be 3 and the total possible outcomes will be 6. And that will be the cumulative probability. What are the chances of me getting 5 or anything greater than 5? If I ask this question, then what will be your answer? 5 and 6. That's called 5 or anything greater than 5. Then how do you calculate cumulative probability? Cumulative probability will be then 2 divided by 6. And that will be the cumulative probability of you getting anything as 5 or greater than 5. So friends, I hope you understood the concept of probability. Probability is chances of an event occurring. And if you want to calculate the chances of an event not occurring, then you can subtract 1 minus probability of the event occurring. And if you want to have cumulative probability, then you need to add the probability of multiple events that you prefer. So this is an introduction about the concept of probability and your cumulative probability. Right? So now what we will do is we will understand how to use this concept in binomial distribution. Okay. Now let's understand this case study. So I have a case study here. Let's understand this. On an average, 2% of transactions processed in a process are defective. On a particular day, out of 400 transactions audited, 21 turned out to be defective. Is this an indication that the process performance deteriorated? Sorry. So what do we understand from this? Let's assume there is a bank where there is teller process, where you fill a challan or you take a check leaf, present it to the teller, and the teller need to check the validity of the challan, the check, and then see whether the required balance is available and the cash need to be handed over to the customer. Or in other words, you take cash with a challan, give it to the teller checks the details and then deposit the cash in your account. This is what we call it as a transaction. So historically, the error percentage of the teller process is 2%. That means out of 100 transactions, 2 transactions turned to be defective. That means the amount you have given, a wrong entry was posted, the amount that is given to you, short cash, excess cash, all these are what we call it as a defective transaction. So in this case study, we need to understand certain terminologies clearly. So what is trials? Trials is nothing but how many cases that you have tested or how many cases that you have checked. So that's what we call it as trials. So in this example, 400 is the number of cases that we have tested. And out of these 400 cases, how many defective transactions that we have identified? 21 is the defective transactions. Okay. And what is the historical error percentage? If you want to call it error percentage, you will call it 2%. But if you want to call it probability, you will call it 0.02. That's the probability of a particular transaction being defective, right? So these are the information that we have got. Now, what is the question? The question is this is this process performance deteriorated? When will you say the process performance is deteriorated? When a particular event is a very, very rare event, a very worst case scenario, generally does not happen that way. But today, if it has happened, then there is something really wrong with the process. The process performance has really deteriorated. If the process is performing almost the same way as any other day, then we will say, no, the process performance has not deteriorated. So now, how are we going to answer this question? The way we are going to answer this question is, we're going to understand what are the chances of me getting 21 effective transactions out of 400 transactions. And if the probability of that is very, very low, then it is a rare scenario. If the probability of that is very high or okay, then it is not a rare scenario. So the answer to the question is going to come from we calculating probability for a binomial distribution. Why do we call it binomial? Because here a single transaction can either be called as an error-free transaction or it can be called as an erroneous transaction. That means this data follows discrete binary data. Discrete binary means a data can either be called as an error-free transaction or it can be called as an erroneous transaction. Only 2 of these options in which data can be represented, and that is what we call it as discrete binary data. And discrete binary data follows binomial distribution. So this is the data in front of us. These are the information that we have captured. So friends, now what we are going to do is we are going to calculate probability. Now there are few things that I want to explain you. This can be done in Excel itself. So in Excel, when you press is equal to symbol and then you type binomial distribution, right? If you type this, if you see here, BINOMDIST, binomial distribution, I can select this. And when I select this, I need to enter basically 4 data points here. What are the 4 data points? Number. So the word number here represents the number of defects that we have identified in this particular example. Trials represents number of transactions that we have audited in this example. Probability represents what is the historical probability of this particular event occurring. And finally, there is a place where I can type cumulative. In the beginning of this video, I have explained if I want to know what is the chances of me getting 5, then I call it probability. What is the chances of me getting anywhere from 1 to 5? Then I can call it cumulative probability. So in this case, what we are going to understand is we are going to understand cumulative probability of me getting anywhere from 0 to 20 errors. I'll tell you why I am calculating for 20 errors, where our case study is actually designed for 21 errors. I'm going to calculate cumulative probability of 20 errors. Okay, I'll explain this, why I'm doing it. So at this point of time, number will be 20, trials will be 400, probability will be 0.02. And finally, do you want to calculate cumulative probability or you want to calculate probability? Probability, I can put 0 and close this particular formula. If I wanted to calculate cumulative probability, I have to enter 1. So at this stage, I'm going to enter 1 because I'm looking for a cumulative probability. So what is the value I'm getting? The value that I'm getting here, let me increase the font size. The value that I get here is the chances of me getting anywhere between 0 to 20 errors. When I audit 400 transactions, what is the chances of me getting 0 to 20 errors or 20 defects, right? The chances of me getting anywhere from 0 to 20 defects is 0.9999923. This is the probability. Now, why did I calculate it for 20 errors and why I did not calculate it for 21, even though our case study is for 21 defects? Because again, in the beginning of my video, I have told you the chances of an event occurring can be calculated. And then if you want to know the chances of an event not occurring, then what you can do is you can do a 1 minus chances of event occurring is nothing but the chances of event not occurring. So now I know the cumulative probability of me getting anywhere between 0 to 20 defects if I check 400 transactions in a process where the historical probability of me committing a defect is 0.02. Now, if I wanted to find out what is the chances of me getting 21 or anywhere greater than 21 errors on a given day, if I want to know this, what I can do, I can say is equal to 1 minus cumulative probability of me committing anywhere between 0 to 20 defects. Now, if I do this, I will be able to find out the chances of me committing anywhere between 21 or greater than 21 errors. So let me change this format to numbers so that it becomes easy for us to understand. So if you see here, the chances of me getting anywhere 20 or greater than 20 errors when I check 400 transactions in a process where the chances of an event or chances of a defect is only 0.02 is very, very, very small probability, 0.000076. So what does that tell us as an answer to the question? The answer to the question is the chances of you getting 21 defects out of 400 transactions is extremely remote. If such an extremely remote possibility has happened today, that tells me there is something seriously wrong with the process. If I am the process owner, I need to immediately stop my process and understand, is there anything wrong with my software? Is there anything wrong with my counting machine? Somewhere something is wrong because of which I am committing a very large number of defects, which is generally not supposed to happen in a process which had a historical error probability of 0.02. So that is the answer to this question. As part of this, you would have understood how to calculate probability for binomial distribution. You would have also understood how to calculate cumulative probability for a binomial distribution. And you would have also seen how you will use this probability of an event not occurring. That is 1 minus probability of event occurring is the formula to calculate probability of an event not occurring. And that one you would have understood. And with all these concepts, we got the answer to our question. Friends, now I will take you to Minitab because all these that we are discussing, we should also know how to do it in Minitab. So in Minitab, now we will understand how we will make use of this particular case study if at all we want to solve it in Minitab. So here I enter defects. And here I'm going to enter 20. Why I'm going to enter 20? Because I'm going to calculate cumulative probability of me committing 20 defects, right? So I'm going to call it cumulative probability, right? Okay, I want to know the cumulative probability of me committing 20 defects so that I'll be able to identify in a process what are the chances of me committing 21 defects. So I can click on cal. I can click on probability distribution. And in probability distribution, I can select binomial distribution. Why binomial? Because the data is discrete binary in nature. And in Minitab, I have two options. I can either have a check mark on probability or I can have a check mark on cumulative probability. In this case, I have already told we are going to calculate only cumulative probability. A number of trials, 400. Event probability is nothing but your historical probability of making a defective transaction, which is 0.02. And the input column, I'm going to take my data from defects column. I can even enter 20 directly here, but I have taken it from the data which I have saved in column C6. Now I can give an optional storage. I'm going to give optional storage as my C7. That is where I want the cumulative probability to be calculated and represented. Now I say okay, and here if you see, you will get the cumulative probability. So the same formula that we saw in in Excel, the same data you will be able to find here in Minitab also. And this tells you that how to calculate this. So again, this is a data which I have taken from Minitab, right? This is Excel formula. This is the data that I have taken from Minitab. Both are exactly same. And if I wanted to find out what is the difference, I can say is equal to 1 minus this, and I'll still be able to get the same value. So friends, I hope this video was useful. As I told before, there is a separate video on how to calculate probability for a data which is normally distributed. I will share the link of that video in the description. We are also planning to upload another video on how to calculate probability for a Poisson distribution, count of a particular event occurring. This is a discrete binary data, that is discrete count data. So we will also upload a video on that. So please subscribe to our channel to get more videos on statistical concepts, Lean Six Sigma concepts, continuous improvement concepts. Hope this video was useful. See you in another video. Till then, thank you for watching.